Hello, everyone, and welcome. I'm glad you're here today. We're about to dive into the Wastewater Certification Exam Review Part 1. This will be a comprehensive practice session focusing on key topics you'll need to succeed. We'll cover safety protocols, equipment operation, chemical handling, and system maintenance. By mastering these 75 questions, you'll be well on your way to passing your certification exam and advancing your career in wastewater management. Let's get started. Let's talk about safety and chemical handling fundamentals, starting with chlorine gas properties. Chlorine gas is non-flammable, which is good to know, but it is highly hazardous. That means we need to be very careful when handling it. Proper ventilation is essential, especially near the floor level in feed rooms, because chlorine is heavier than air and tends to settle low. In case of an emergency, using self-contained breathing apparatus is critical to protect ourselves. Also, material safety data sheets, or MSDS, are our go-to sources for vital information. They detail the properties of chlorine, the hazards involved, and the precautions we should take during handling. Now, moving on to gas testing requirements. It's crucial that our gas test equipment can accurately detect hazardous atmospheric levels. The equipment should also produce audible alarms to alert us immediately if danger is present. Regular testing of this equipment is necessary to ensure it remains accurate and reliable. One of the most important measurements we look at is the LEL, or lower explosive limit. Monitoring this is vital, especially in confined spaces, because it helps us identify if explosive concentrations are approaching dangerous levels. Next, let's discuss emergency protocols. Before entering manholes or confined spaces, we must check the atmosphere to ensure it is safe. We need to verify that our equipment is in proper working order and that barricades are properly set up to secure the area. Legislation like Right to Know requires employers to provide material safety data sheets. These sheets are essential because they inform us about the potential health effects from contact with hazardous materials, so we're fully aware of the risks involved. Connecting all these points, the overall theme is that safety begins with understanding the hazards, using the right tools to monitor conditions, and following proper procedures. This approach helps us protect ourselves, our colleagues, and the environment while handling these dangerous chemicals. Now, let's talk about chlorine safety and equipment. First, fusible plug protection plays a critical role. Chlorine cylinders are equipped with fusible plugs that melt between 150 and 165 degrees Fahrenheit. This melting acts as a safety mechanism to prevent explosions during a fire. For larger tanks, like the 1-ton cylinders, the fusible plugs are located at the valves and need to be secured with locking devices to prevent the tanks from rolling when connected. It's also essential to store these tanks properly, ensuring that any liquid chlorine is removed from the top valve to reduce risks. Moving on to emergency response. If there's a major chlorine leak, the first step is to call the fire department immediately. You should also notify local police or sheriff's office. If possible, submerging the leaking container in a basin or stream can help contain the leak. When entering areas with high chlorine concentrations, always use self-contained air or oxygen supplies and have help standing by. Never just hold your breath or try to use a wet handkerchief. That's not safe. Now, ventilation is another key point. Since chlorine gas is heavier than air, ventilation in feed rooms must be near floor level to effectively remove the gas. Exhaust fans should be positioned to pull air from the floor, not from the ceiling or entrances. Proper ventilation design is absolutely critical for operator safety. Finally, let's touch on the hypochlorinator. This device feeds liquid chlorine solution into water systems for disinfection. It's different from equipment that measures residual chlorine or treats iron and turbidity. When operated correctly, it ensures effective disinfection while maintaining safety protocols. Understanding these safety features and procedures helps us protect ourselves and maintain safe operations when working with chlorine. Let's talk about electrical systems and how we control flow within them. First, understanding measurements is crucial. When we're measuring flow or current in electrical circuits, we use amps. Voltage is measured in volts, power in watts, and resistance in ohms. Grasping these concepts is essential, especially when troubleshooting electrical issues in wastewater facilities, because accurate measurements help us pinpoint problems quickly. Now, moving on to flow control valves. Globe valves are typically used when we need to control or throttle flow precisely. They allow us to adjust the flow rate as needed. Other types, like gate valves, plug valves, and ball valves, each serve specific functions depending on the application. Check valves are also important. They prevent water from flowing backward, which helps avoid issues like water hammer, a sudden pressure surge that can damage equipment. Let's also touch on motor types. Squirrel cage motors are the most common AC motors we use. They're straightforward with rotors made of bars placed in slots. These motors are the workhorses of pumping stations. We usually measure their shaft speed in revolutions per minute, or RPM, to monitor performance. Safety is a big deal in electrical systems. Devices like circuit breakers, overload protectors, and ground fault protectors are there to keep everything safe. For example, fuses contain metal strips that melt when there's too much current, preventing damage. Whenever you're working on electrical circuits, always disconnect the circuit breaker first. Then, place a red tag that says, "Do not activate and lock out the system, safety first." Connecting all these points together, understanding how electrical systems function, and how to control and measure them is fundamental for maintaining reliable and safe wastewater treatment operations. Now, let's take a look at some of the main types of collection systems and the challenges they face. First up are combined sewers, which are designed to carry both wastewater and storm or surface water runoff in a single pipe. While this system is efficient, it can lead to combined sewer overflows, or CSOs, especially during heavy rain events. These overflows are harmful to the environment, but the good news is that they are controllable. One of the best management practices gaining popularity is the use of swirl concentrators, which help treat and manage these overflows more effectively. Next, we have infiltration and inflow, or I&I, which need to be carefully controlled. If these are not managed, they can cause hydraulic overloads in the system. This can lead to serious issues like system failures, overloading the treatment plants, and even environmental impacts. Regular monitoring and maintenance are crucial here to prevent these problems before they escalate. Finally, let's discuss gas hazards within collection systems. Gases with a specific gravity greater than 1, like hydrogen sulfide, tend to settle in low-lying areas because they are heavier than air. You can often tell there's hydrogen sulfide present by its distinctive rotten egg smell, and it can cause oxygen deficiency and even deterioration of manhole walls. Interestingly, these hazards are not indicated by high wastewater pH, so awareness and proper safety measures are essential to protect workers and the environment alike. Let's talk about pump operations and maintenance. First, the configuration of pumps can significantly impact system performance. Pumps connected in series are used to increase pressure, which is useful when you need to push water over long distances or to higher elevations. On the other hand, pumps in parallel are designed to boost flow rates, providing more volume when needed. Understanding these configurations is essential for designing efficient systems and troubleshooting issues effectively. Remember, the pressure a pump works against is measured in pounds per square inch, or SI, which helps us monitor and control performance. Next, let's consider cavitation and NPSH. Cavitation happens when there's not enough net positive suction head, or NPSH, available at the pump inlet. Specifically, the NPSH, the available head, must be greater than the NPSHR, the required head, for the pump to operate properly. If cavitation occurs, it can cause noise, reduce efficiency, and even damage the pump, so it's something we want to prevent through proper system design and maintenance. Moving on to bearing failure indicators, the most common sign is noise, unusual sounds coming from the pump. Other clues include a drop in discharge flow or strange vibrations. Regular monitoring and preventive maintenance are crucial here. They help us catch issues early and avoid costly failures down the line. When it comes to pump types, centrifugal pumps are most frequently used in public water systems because they're reliable and versatile. Vertical turbine pumps are excellent for boosting pressure in large distribution networks, and submersible pumps offer benefits like minimizing vandalism, operating quietly, and fitting into crooked or tight spaces. Lastly, internal leakage is another factor to keep an eye on. If you notice performance degradation, it could be due to excessive internal leakage, often caused by wear in the wear ring. Checking and maintaining this component is vital for keeping your pump running efficiently and avoiding bigger problems down the road. All these points tie back to our overall goal: ensuring pump systems operate reliably, efficiently, and safely through proper understanding, monitoring, and maintenance. Let's talk about pump safety and lockout procedures, which are essential for protecting both the team and the equipment. First, electrical lockout is crucial. You need to lock out the motor electrically and attach a warning tag. This step prevents accidental activation while you're working on the pump. Next, hydraulic isolation involves isolating the pump hydraulically using valves, and it's equally important to attach the appropriate warning tags. These tags alert other operators that maintenance is in progress and that the system is isolated. Then there's pressure relief. Before starting any disassembly, always relieve pressure from the pump, the valves, and any related equipment. This step reduces the risk of sudden releases that could cause injury. Finally, verification is key. Before you begin dismantling the lift station pump, double-check that all safety steps, electrical lockout with tags, hydraulic isolation with tags, and pressure relief, are completed. Remember, completing all 3 steps is the critical safety requirement. It ensures the safety of the operator and prevents damage to the equipment. These procedures are fundamental to safe maintenance practices and align with our overall safety goals. Now, let's talk about packing and sealing systems. When installing packing in a stuffing box, if only 2 rings are used, it's important to stagger the joints by 90 to 180 degrees. This staggering actually helps prevent leakage paths and ensures a more effective seal. Remember, the joints should never be aligned directly on top of each other, as that can create a weak point for leaks. Next, when it comes to potable water protection, if you're supplying clean water to pump water seals, you need to include a vacuum breaker in the connection. This is crucial because it prevents backflow, which could contaminate the potable water supply. The simplest and most effective method is to have an air gap between the systems or use a reduced pressure zone device, both of which eliminate cross connections and help maintain water safety. Finally, let's talk about priming systems. Foot valves play a key role here. They're used to keep the pump primed. Essentially, they prevent water from draining back through the pump when it's not running, which means the pump is always ready to go when you need it. This small component makes a big difference in maintaining pump efficiency and readiness. All these systems, packing, sealing, potable water protection, and priming, are interconnected parts of ensuring reliable, safe, and efficient pump operation. Let's take a closer look at velocity and flow calculations. The key formula here is V equals D divided by T, which means velocity equals distance over time. This is a fundamental concept because it helps us determine how fast something is moving, and that's crucial for many aspects of our work. For example, calculating flow rates, assessing how effective cleaning is, or troubleshooting issues within the collection system all rely on understanding velocity. When operators know the velocity, they can optimize system performance and catch potential problems early before they turn into bigger issues. Now, moving to some specific velocity parameters. The minimum velocity we need to prevent solids from settling out in the collection pipes is about 2 to 3 feet per second. This ensures that solids stay suspended and don't accumulate, which could cause blockages or backups. On the other hand, we have a maximum velocity of around 100 feet per second. This is the upper limit to avoid pipe erosion and excessive turbulence, which could damage the system over time. Finally, let's discuss the flagger distance. When working near the collection system, the flagmen should be positioned at least a minimum distance of 10 feet from the work area. This safety measure helps ensure clear communication and safety for everyone involved. All these points, velocity, flow rates, safety distances, are interconnected and essential for keeping our collection systems running smoothly and efficiently. let's take a closer look at sewer cleaning equipment and methods. First, regarding root removal, power rodders are really the go-to for clearing out root stoppages in sewer lines. They're quite effective because they can break through those stubborn roots. High-velocity cleaners are also useful for many applications, but it's important to remember their limitations. They're not very effective in cleaning large diameter pipes or in emergency blockage situations where quick, thorough cleaning is needed. Moving on to hydraulic cleaning methods, these include tools like parachutes, kites, and sewer balls. They're designed to handle different pipe sizes and types of blockages. It's worth noting that bucket cleaners are mechanical, not hydraulic, so their use depends on the specific situation. Each of these methods has its own ideal application depending on the pipe size, the type of blockage you're dealing with, and how accessible the pipe is. Now, for heavy-duty cleaning in larger pipes, power bucket machines come into play. These use various accessories like yokes, rollers, jacks, swivels, pull-in machines, and loaders. They're essential because they provide the power and versatility needed to tackle tough cleaning jobs in bigger pipes. Finally, inspection and testing are crucial for ensuring everything is functioning properly. Dye testing helps verify sewer connections and flow patterns, making sure everything is connected correctly. Television inspections, or TV camera inspections, are invaluable. They can detect improper connections, obstructions, or damage inside the pipe. When performing these inspections, it's important to record the distance from the manhole to the observation point, and the camera's footage meter should read 0 when the camera first enters the pipe on the downstream side. All these methods and equipment work together to keep sewer systems clean, functional, and reliable. Let's talk about the key steps involved in manhole inspection and emergency response. First, when we encounter an overflowing sewage manhole, the very first thing we need to do is assess the situation. We have to identify what's causing the overflow, whether it's a blockage, equipment failure, or maybe a system overload. Understanding the root cause is crucial for applying the appropriate fix. Next, once we know what's wrong, we need to take immediate action to correct the issue. This could mean clearing a blockage, repairing or replacing faulty equipment, or managing the load on the system. The goal here is to stop the overflow as quickly as possible to minimize environmental and public health impacts. After fixing the problem, it's important to clean the impacted area. This step helps prevent environmental contamination and protects public health. We want to make sure the site is safe and that there's no residual risk to the community. Finally, we must report the incident to the proper authorities and regulators, as required by regulations. This step is non-negotiable. Reporting must be completed even after fixing the issue and cleaning up. Proper documentation not only keeps us compliant, but also protects both the operator and the organization. Remember, all 4 steps are essential. Skipping any of them could lead to bigger problems down the line, so thoroughness and accountability are key in managing these emergency situations effectively. Let's take a closer look at lift station controls and monitoring, starting with bubbler system blockages. When we use pressure-sensing controllers, like the bubbler system, the system depends on air pressure to monitor water levels. If there's a blockage in the air line, it prevents the pump from running because the system can't detect the water level properly. It's important to remember that any disruption in the air pressure signal can cause the system to malfunction, so regular checks are key. Now, moving on to alarm response priority. When an alarm sounds at a lift station, the first step for operators should always be to inspect the motor control center and power panel. This helps us quickly determine if the problem is electrical, like a power issue, before diving into mechanical or hydraulic problems in the wet well or dry well. Addressing electrical issues first can save us time and prevent unnecessary downtime. Finally, let's discuss pump performance issues. If the back pressure on a pump drops too low and the pump runs for too long, efficiency drops, and the pump starts to heat up. Over time, this can lead to seal failure, damage to the bearings, and ultimately, pump failure if we don't act. So, keeping an eye on pump operation and addressing low back pressure early is crucial for maintaining reliable system performance. Connecting all these points, it's clear that vigilant monitoring and timely responses are essential parts of effective lift station management, ensuring everything runs smoothly and avoids costly repairs. Now, let's look at some key strategies for traffic control and work zone safety. First, pre-warning is crucial. We need to alert motorists well in advance of the work zone, using appropriate signage and advance flagger stations. This helps drivers slow down and prepare for what's ahead. Next, controlling vehicle speed is essential. We do this through a combination of signs, flaggers, and traffic control devices to ensure vehicles move at safe speeds through the work area. Then, guiding traffic properly is vital. Clear and visible guidance systems are used to direct vehicles safely through or around the work zone, preventing confusion and accidents. And don't forget the position of the flagger. They should be placed at least 100 feet from the work zone, standing in the travel lane near the center line, but not in the opposing lane once the first vehicle has stopped. All these measures, pre-warning, speed regulation, traffic guidance, and proper flagger positioning, are interconnected. Together, they form a comprehensive approach to keeping both workers and motorists safe. When routing traffic through a work area, it's important to take all these precautions seriously. They're the foundation of effective work zone safety management. Let's talk about excavation safety and shoring. First, the concept of a competent person is crucial. This is someone on site who can identify hazards and has the authority to take corrective actions. They're responsible for ensuring safety and must complete written inspections before anyone enters an excavation. Now, they don't need to be a professional engineer, but proper training and authority are essential. Moving on to shoring removal procedures. When removing screw jacks used for shoring, it's important to do so from the top down. This order is the opposite of how they were installed, and following it helps keep the excavation stable. Never remove shoring from the bottom up, as that could cause the walls to collapse. Now, let's consider the common excavation hazards. These include cave-ins and soil collapse, which are some of the most serious dangers. Falling materials and equipment pose risks as well, along with potentially hazardous atmospheres and water accumulation. Underground utilities are another hazard to be aware of, and mobile equipment adds to the complexity. Finally, the key to preventing injuries and fatalities in excavation work is proper planning, regular inspections, and the use of protective systems. Staying vigilant and following these procedures helps keep everyone safe on the job site. Let's start with pH and litmus testing. When we dip litmus paper into an acid solution, it turns red. Conversely, blue litmus paper turning red indicates an acidic environment, while red litmus paper turning blue signals a basic or alkaline condition. This simple test is incredibly useful because it allows operators to quickly assess water chemistry without complex equipment. It's a handy tool in ensuring water quality and safety. Moving on to coagulation timing, this process happens remarkably fast, within the first 1 to 5 seconds of starting treatment. Coagulation is vital because it helps remove particles and contaminants from the water efficiently. To get the best results, proper mixing and precise chemical dosing are essential. This rapid reaction underscores the importance of well-maintained equipment and careful monitoring during treatment. Now, let's discuss nitrate health risks. Nitrates in water can lead to a serious condition called methemoglobinemia, or blue baby syndrome, which primarily affects infants and can be life-threatening if not addressed promptly. That's why monitoring nitrate levels in drinking water is so critical. Ensuring safe nitrate concentrations helps protect vulnerable populations and maintain overall water safety. On odor control, hydrogen peroxide can be used effectively in septic sewer systems. It works by oxidizing hydrogen sulfide and other odorous compounds, neutralizing unpleasant smells. This method is a safe and efficient way to manage odors naturally without introducing harsh chemicals. Finally, regarding corrosion resistance, vitrified clay pipe is the least susceptible to corrosion caused by acids from sewer gases. In contrast, Cast iron and concrete pipes are more vulnerable to acid attack, which can compromise their integrity over time. Choosing the right pipe material is an important part of infrastructure durability and long-term maintenance. All of these points tie back to our overall goal: ensuring water quality, safety, and infrastructure longevity through proper assessment and maintenance techniques. Let's take a closer look at well systems and drawdown. First, we have the normal level, which is the static water surface before any pumping occurs. This is essentially the natural, undisturbed water level in the well. When we start pumping, the water level drops to a lower point, which we call the pumping level. The difference between these two levels, the normal level and the pumping level, is known as drawdown. Drawdown is a critical measurement because it helps us understand how the well and aquifer are performing, as well as their characteristics. Now, the zone of influence is the area outward from the well where the cone of depression. This is the cone-shaped lowering of the water table, affects the normal water level. Understanding this zone is key to preventing well interference, which can happen if neighboring wells impact each other, and it helps us design more efficient well fields. Moving on to drawdown analysis, if we observe that the drawdown is decreasing while the water level remains stable, that's a red flag. It usually indicates that the aquifer is being pumped faster than it can recharge naturally. This situation is unsustainable and can lead to aquifer depletion, which we definitely want to avoid. That's why monitoring drawdown trends is so important. It allows operators to identify potential problems early on and make adjustments to pumping rates or well field management, ensuring a sustainable water supply for the long term. Let's take a closer look at pressure and head concepts. Now, one key thing to remember is that 1 psi, or pounds per square inch, is equivalent to approximately 2.31 feet of water head. This conversion factor is really useful when we're working between pressure and the height of water, or head, in a system. Conversely, if we know the head in feet, we can convert that back to psi by using the factor 0.433. It's also important to remember that water weighs about 62.4 pounds per cubic foot at standard temperature. That weight influences how pressure and head relate to each other. Now, when we talk about pressure head, it's caused by water pressure itself, not by the flow of water, gauge pressure alone, or simply the water's elevation. This distinction is essential because understanding the relationship between pressure and head is fundamental to pump operations and system design. Operators need to be proficient in converting between psi and feet of head. This skill allows us to properly size pumps, troubleshoot issues effectively, and optimize overall system performance. So, mastering these conversions helps us make better decisions and keeps our systems running smoothly. Now, let's talk about record keeping and system management. First, sewer map maintenance is crucial. Keeping these maps up to date helps us plan television inspection programs more effectively, connect new house services with ease, and develop better street improvement plans. It's important to note that census data on living standards isn't really relevant for maintaining sewer maps, so we focus on the practical aspects instead. Next, organizational charts are a helpful tool to show the structure of an agency. They illustrate reporting relationships, departmental divisions, and lines of authority, which are essential for understanding how the organization functions. However, they don't show how the collection systems are organized or how to locate specific sewers. That's a different kind of information we need to gather separately. Moving on, the industrial waste section has a key role. Their main duty is sampling and testing industrial discharges. This is vital because it ensures industries comply with pretreatment requirements and helps protect our treatment plants from harmful discharges that could cause damage or operational issues. Finally, during television inspections of sewers, operators must record specific details. They should note the distance from the manhole to what they observe, and the camera footage meter should read 0 when the camera enters the pipe on the downstream side. This standard helps us get accurate location data for any defects or needed maintenance, ensuring we can address issues precisely and efficiently. Now, let's take a closer look at some key equipment characteristics and how to select the right components for our system. Starting with submersible pump features, these pumps are quite versatile. They can be installed even in crooked holes, which gives us more flexibility during installation. Plus, they help minimize vandalism since they can be placed in secure, less accessible locations. One of their advantages is that they operate more quietly compared to other types of pumps, making them ideal for locations where noise reduction is important. However, it's important to remember that they do require water lubrication, which is typical for submersible designs, so proper water supply is essential for their operation. Moving on to pump priming, this is a critical step to ensure the pump works efficiently. Foot valves are commonly used here. These check valves are installed at the bottom of the suction line and serve a vital purpose. They help maintain the prime by preventing water from draining back when the pump stops. This means the pump can restart quickly and operate smoothly without needing to be reprimed each time. Next, let's discuss motor selection. Squirrel cage motors are the most straightforward and reliable choice for many wastewater applications. Their design features a rotor made of bars placed in slots, which makes them simple and durable. Because of this simplicity, they tend to be cost-effective and require less maintenance, making them a popular choice in our industry. Finally, on valve applications, different valves serve different functions. Globe valves are excellent when we need precise control over flow, such as throttling. They allow us to adjust flow rates accurately. Gate valves, on the other hand, are better suited for on-off operations. They open fully or close completely. Butterfly and ball valves serve other specific purposes, often chosen based on the particular application's needs, such as quick shutoff or flow regulation. Understanding these characteristics helps us make informed decisions when selecting equipment, ensuring reliability, efficiency, and longevity in our wastewater systems.